UML use case diagrams help us to plan the features of our system by identifying how all of our users will interact with the system. Use case diagrams are the second type of UML diagram that we will use in this course and represents a high-level analysis of our system. With our use case diagrams, we want to identify how users will interact with the system. Who will be using our system? What actions can they take? What choices can they make? What interactions do we need to support? And what will our users need from our system? These are usually the first diagrams that we will develop when designing our system, as they give us an understanding of the big picture. These also help us make sure that we are accounting for all necessary stakeholders and all necessary functionality. Use case diagrams depict the primary actors in the system and their interactions with the system. How will these users use this system, and what actions will they need to take? We don't represent any ordering between these actions, but we do represent who or what triggers an action in the system. In this simple example, we are building a software system that manages a checkout system in a grocery store. The system will optimize the customer and cashier interactions in order to make the checkout process less frustrating and more efficient. Here we see a customer and a cashier as the two actors in the system. The customer triggers the first action, which is to choose a cashier line, and joins it. The arrow indicates that the customer is triggering this action. Once the customer has joined a line, this action then triggers the cashier to complete checkout. Obviously, a cashier should not attempt to check someone out if there is no customer in line, which is why there is an arrow from the Choose Cashier action to the cashier. Once there is a customer in line, the cashier can then complete checkout. The most basic elements of a use case diagram are the actor, the use case, and the association. Actors represent decision makers in the system and may be either human or artificial intelligence agents. In either case, actors are represented by stick figures. Use cases are the ellipses and represent actions the actor will take. These should always start with a verb and represent a high-level concept. It is important not to get too detailed with these, as that will clutter your diagram. We'll discuss next how we can create hierarchical diagrams using packages. For example, in the top diagram, we have the use case check-in passenger. In reality, this is a multi-stage process that requires that the passenger or clerk enter in a bunch of information, including the passenger's name, the reservation number, driver's license or passport number, and any other number of elements. We ignore these details at this level of the system design, as they will be specified in other diagrams. Finally, associations between the actor and the use case, or between use cases, are represented by lines. The arrowhead is optional, but when used, indicates which entity triggers the other. In the bottom hand-drawn version, we see that a student can enroll in a university, and that involves the registrar, but the registrar doesn't trigger the enrollment. Here we see a more complex system that represents a grocery store simulator, where the artificial intelligence agent that runs the simulation requests the rate of customer arrival from the human user, which is not represented in this system. The simulation then can generate customers or add or remove cashiers. If a customer was generated, the customer chooses a cashier line. The cashier can check out a customer if there is one in their line. When customers are checked out, the system then updates statistics by using the current time. Notice that getting the current time is reused by both generate customer and checkout customer, as we want to keep track of how long a customer waits in line. A few more advanced features can optionally be used to further describe or simplify our systems. Relationships between entities can be described by using angle brackets around a custom term. The most commonly used relationships describe those of reusing components. Includes indicates that one use case uses another use case as part of its operation. Extends indicates a custom extension of a specific use case. We can then group use cases together using system boundary boxes to indicate related components or even software versions or releases. Finally, packages can be used to cluster related components to help simplify and organize large use case diagrams for large systems, so that subsystems can be better understood, explored, or designed. Here we see a large system that represents part of the university's systems. We can see the wide variety of actors involved in the system, from students to instructors to researchers. Even outside institutions are included, as they represent entities that the university must interact with, such as financial institutions and the post office. We also see a good use of the extends relationship. Distributing transcripts, fee schedules, or class schedules are extensions of the process of distributing information to students. This process involves the post office, as letters are dispatched through the post office to students. These distributions are triggered by the registrar.